Greetings everyone. In this section we will see that how we can do binary image classification. We will see how we can use PyTorch Lightning and how data flows from folders to the GPU and how the training and validation process happen. We will see in this section in detail. The dataset I am using is taken from this repository COVID city, and if you go to this repository at GitHub, you have to go to the image process folder and you have to download this 2-zip file. After the download is complete, you have to extract that and put it in this way, such as city COVID is a folder and there are CT scan images inside it. Similarly, city non-COVID is another folder and there are many images inside this folder. So first step we have to do is to import the packages. I am using a lot of packages such as NumPy. This will take some time. So these are the packages we are using: NumPy, Pandas, Matplotlib. You are familiar with that. Torch is basically PyTorch. Torch Vision it has some functions of PyTorch, such as it has models, pre-trained models, and it has augmentation functionality. Torch.nn is basically used to write a neural network. Torch matrix is used to calculate accuracy, precision, F1 score, and things like that. Models is basically where in Torch Vision where pre-trained models are present, and we are using data loader, which actually load data from the folder to the CPU, and random basically split the data into train and test and dataset if we need some customization in our data. Then we are using PyTorch Lightning functions such as seed everything, which makes sure that whenever you run the code, the same results are obtained. There is no randomness in the code in the production. Lightning module is basically a class and we are inheriting from this class. We will see that later. Trainer is used to train our deep learning model, and classification report from scikit-learn. I hope you are familiar with that. So let me import these libraries. The next step, I have to see how my data look like. So I will do ls and it will print me the file which is in my current directory. So if I do ls dot, it will go one step up in a folder and it will show binary, which is a folder code, and multi-class and multi-label folder, which are actually this section. So I will go to this binary. So if I do binary, there are two folders, city COVID and city non-COVID, which has images of CT scan, which I have shown you there. CT scan images of COVID and non-COVID. So next I have to do is to import this dataset into PyTorch. Actually, I am using PyTorch and PyTorch Lightning combined. So let me do dataset equal to Torch Vision dot datasets dot image folder. It will pick the classes from the image folder on this path. So if I do this dataset is actually, it doesn't load whole of the images, but actually it loads their path and their label. That the path where the image is located and the name of the folder, which is actually the label of the folder. The next thing I have to do is to pass this dataset to the data loader. But before that, I will do augmentation, because I want my model not to overfit. Augmentation help our model to generalize well, and I am using a few augmentation. A very few augmentation which are actually necessary augmentation. I'm not using flipping, rotation. I'm just using resize and normalization. So let's do aug equal to, actually I'm storing it in a variable so that I can use it later. Transforms dot compose. This section of this tutorial is actually showing you how data flows. In the later part, we will see that how we can combine into one class, which is actually inherited from the Lightning module. transforms dot resize, which actually resize the image. Resizing is an important thing. If you don't resize, then your model will give error. Transforms to tensor. Actually, the transform to tensor is very important because when the data set is passed to data loader, the data loader expects the data set in a tensor form. It doesn't expect the data in an image format. It is expecting it in a tensor format. The third very important and necessary transformation is normalization. It helps to converge our model faster, and we are using this for the model to normalize well, as we are using pre-trained models, and the ImageNet data set has some average and some standard deviation. So we want to keep the same average and the same standard deviation, that is ImageNet data set, because we are using pre-trained model from ImageNet. So I'm using mean is equal to 0.485, which is actually the average of the first channel, that is RGB, because we are talking about RGB channel, that is the mean of the R channel. Then 0.456, which is the mean of the green channel, and 0.406, which is the mean of the blue channel. The next thing, I am defining a standard deviation, and similarly I will define it for each channel. If you are dealing with grayscale image, then you have to define a single value, because there is only one channel in grayscale image. Though it's a grayscale image, but we are loading it as a 3-channel image. So transforms, and then I have to pass the transformation to here. Transform equal to aug. Okay, it basically transform. Where did I? The next thing, let me check the shape of the data, that how many images are in the data, and how I can split the data into train and test. Print length of data set. There are 746 images in the data set. If I take 0.75% of the images as train and 0.25 as test, then see how many images are in train and test. Okay, there are 559 images in train and 186 images in test. Actually, if I round that, it will 559 and 186, and when we add them, it will not be equal to 746. So I will floor one value, which is actually train data set, and I will seal the other, which actually, if I do np.floor 559.5, np.floor 559.5, it will make it 559. If I do SEIL, then it will make 560. So during splitting, we have to make sure that sum of the train and test will be equal to the should be equal to the number of images in the data set. So let me use a random split, which we have used earlier, but before that, let me prove the assumption that sum of train and test data set should be equal to the total number of images in the data set. So np.floor length of data set, it will make it 559, and then I will convert it into integer, because I don't want 0.0 and maybe it will give an error, so I need to convert it into integer. Okay, then next I have to do the same with the test set, but I have to do it with seal. If I do both with floor, then it will not be equal to the number of images in the data set. So now it will equal to the number of images in the data set, which is 746. Now we will use the random split function to split them into train and test. Train set, val set. in this section, sometime I will use val set as test set and test set as val set, but when we have a separate test set, we will use the terminology of test set, but here I will use it interchangeably, that sometimes I call it val set, validation set, or sometimes I will call it test set. Random split. Data set we want to split, and then we have to pass this thing. First we will pass the shape of the train set, and then we pass the shape of the test set, but we will pass it in a list. And let me close this section. Okay, so there are some, look like there are some issues with that. Let me figure it out. Okay, now let's check the shape. Now let's check the shape of the train and validation set, which is test set or validation set in this case, because we don't have a separate test set. So we have 559 and 187 images in train and test set respectively. The next thing I will do is pass this train set into the data loader, and I will call it train loader equal to data loader, which is actually this function, and it will accept train set and few other parameters, such as do you want to shuffle the data set, we want to shuffle the data set, or what is the batch size of the data set. The batch size we want right now is 8, and what is the number of workers? Number of workers set to 0. What happens when a data loader is called? The data set we define here does not have images. It has paths and labels of the images. When data loader is called, an image is taken, then another image is taken until the number of images taken is equal to the batch size. When the number of images taken equal to the batch size, then the data loader create a batch of the image. And this step is sequential step. But if we define number of workers equal to 2 or more, like 24, then it will become a parallel. The number of workers depend upon the processor in your system. I have 24 processor, I can define 24, but for the most system have 2 or 4 processors, so I will use 2 or 4. So it will speed up the loading of the data. If you define 0, then it will load one image, then another image, then another image. So the GPU has to wait, so because images are being loaded by CPU, so this will increase the time of your computation. So this is train loader. So what happens if we don't define augmentation here? Let me correct this section so that we can see that what error we will get. So let me call this again, and when I call this, nothing happens because we haven't called the batch. Batch equal to next iter train loader. So what it will do, it will iterate a batch and it will give an error. The error say that batch must contain tensor, numpy arrays, or numpy arrays, numbers, dictionaries or list, found, class, bill, image. It says that this function accept either tensor, numpy, number, dictionary or list, but it contains below image. So I have to define augmentation here so that it convert it into numpy array. Sorry, it will convert it into tensor. So this is let me define the shape, what is in batch 0 and what is in batch 1. Batch 0 is actually images and batch 1 is actually label. As we have defined batch size 8, we have 8 images which have 3 channels and shape is 224 by 224, and there are labels like this. These are 8 labels. Next, let me plot these images. that we have called plt dot figure. Figure size should be like whatever is feasible for you. I am taking it 16,16, and next I have to take a grid image, which is actually a built-in function in Torch Vision. Torch Vision dot utils dot make grid, and I will pass batch 0. Next, I will define how many rows I need and how many columns I need. First, I will define how many columns I need. I need 4 columns and I need 2 rows. Then let me plot plt.imshow and grid image. The next thing I have to make sure is that when in matplotlib the channel should be in last index, but here the channel is in first index. 0 index is the batch size, channel index is the first index, so I have to move it to the last index. So I will do permute. First I will define what should be the dimension. So it will look like this. If I show you the permute without permute, what is the shape? The shape without permute is basically 3, 4, 5, 4, 5, 6, this one. And what is the shape after permute? Let me plot the shape. Actually, it moves the channels after the at the last index. So this is the shape of the data. So this is the part 1 where we have seen how we can load data, how we can plot data, and what is the benefit of using augmentation, because we want our image in tensor format and it helps us to avoid overfitting. We will use further transformations such as flipping, rotation when we build our further part of this tutorial series, and how we can split this data. We have seen this in this section.